friends, welcome to my YouTube channel Forcetra. Myself Mudita Bansal. In this video, we are going to solve previous year IBDP paper 1 questions. We will solve 5 questions and the next 5 questions would be in next video. Forcetra, precision learning and powerful results. So contact us for one-to-one tutorials or any doubt solving classes. You can mail me on forcetra.physicss@gmail.com or WhatsApp me on this number. Or to book any session with me, you can scan this and DM me on the WhatsApp. An object oscillates at free end of a vertical spring. The graph is shown in the position versus time. At what position does the object have zero velocity and negative acceleration? So V is equal to 0 and acceleration should be negative. So let's see. At position A, when it is at position A, so it is starting with the position 0 at time is equal to 0. So if this is a spring and this is the x position, x is equal to 0. So this is the starting point, time is equal to 0. So at this point where the displacement is maximum in the positive side, because it is positive side and c is the negative side. So x is the amplitude at this point, or x max. At this point, when the maximum stretching is there, so spring would be stretched or maximum stretch at this condition, and the restoring force in this direction. And since it is negative side, so the acceleration in this case would be negative. And the velocity at this point is 0, because at this point it stops for a second, and after this the velocity starts growing, and at x is equal to 0 velocity is maximum. So at B and D velocity is maximum but not 0. In C, at point C, which is at the compressed state, like when the spring is compressed, this is point C, x is equal to minus a. In this point the acceleration, the force or the restoring force is in the positive direction, and that's why acceleration would be in positive side and the velocity would be 0. So C is not the correct option, A is the correct option, because it has 0 velocity and negative acceleration. So it is fulfilling both the criteria. A is the correct option. The graph shows the variation of distance of a displacement of a particle in a wave. The frequency of the wave is 600 Hertz. So this is displacement on y-axis and this is distance. So what is the speed of the wave? The speed of the wave is equal to the frequency into wavelength. So what is wavelength? Wavelength is defined as the length covered by one wave. So this is your wavelength, because it is one complete wave starting from this point and ending at this point. This is one complete wave and the length covered by this wave is lambda. So lambda is equal to 4 millimeter. So velocity is equal to frequency is 600 and the frequency is 4 into 10 to the power minus 3 meter per second. So when you solve it, it would be 2.4 meter per second. D is the correct option. A point source emits a sound wave of amplitude z. A person stands at a distance L from the source. So this is a source and producing amplitude of sound of amplitude z. And the person is standing at point P, and the distance between this source and the person is L. The amplitude is changed to 2L. Now the amplitude, new amplitude, it is 2Z. What is the distance must the person move through in order to hear the original intensity again? So how much extra distance he needs to cover, x is the new distance he needs to cover to listen to the same intensity that he was hearing at this point. So original intensity, or I1, is equal to z square upon length square. So when the person would move to the new point, which is P dash, so the new intensity in this case would be equal to 2z square, because the new amplitude is there, divided by the length. So the total length from the source would be x plus L plus x, the square of it. And this intensity should be equal because the person wants to listen to the original intensity. So I1 is equal to I2. When we equate it, it would be z upon L whole square of it is equal to 2z upon L plus x whole square of it. So square would get cancelled and z will get cancelled. So I am solving it here. So it would be 1 upon L is equal to 2 upon L plus x. And when you cross multiply, L plus x would be equal to twice of L. So x would be equal to L. So extra distance which he needs to travel is L. A ray of light enters from air into a water droplet of radius r at a point S. S is the vertical distance h from the center of the droplet. The droplet has the refractive index n and has the angle of refraction as theta. So we have to find what is sine theta. So this is air and this is water. Let's apply the Snell's law, which says that sine I incident ray is equal to n times, which is refractive index where the light is entering, into sine r is the refractive index. Let's draw a tangent at point S. So when we draw a tangent, it would be like this, and the radius is perpendicular to the tangent. So I can extend this radius as like this. So it is normal where the light is incidenting. So this angle is I, and if I extend this light ray as like a straight line, if there is no water droplet, so this angle would be I. Sine I is equal to n times of sine r, which is theta in this case, and let's find sine I. So sine I in this triangle, if you see S O and P triangle, if you see this is a perpendicular OP which is equal to H, and R is the hypotenuse. So sine I would be H upon R into N, and this would be equal to sine theta, and we have to find the sine theta. So the correct option is C is the correct option. Let's see another question. A standing wave is formed in a pipe closed at one end. The third harmonic has a frequency of 400 Hz when the speed of the sound is 300 meter per second. What is the length of the pipe? So when the pipe is closed from one end, this is the fundamental or first fundamental harmonic or the first harmonic, and the second harmonic, which we called as third harmonic because there is no second harmonic. So this is the third harmonic wave. This is your third harmonic, and we know that the length of this wave is lambda by 2, and this is, now since this is half of the half wave, so it would be lambda by 4. So the length of this pipe would be equal to lambda by 2 plus lambda by 4, and when you, it would be 3 lambda upon 4. So to find lambda, we know that the velocity is equal to the frequency into lambda. So frequency is given to us, which is 400, and lambda we have to find, and the velocity is given to us is 300. So lambda is equal to 3 upon 4, and lambda in this case equal to 300 upon 400. When you solve it, it would be 9 upon 16. B is the correct option. Thank you for watching. Like the video, comment it, and subscribe my channel so that you can be updated on the next post. See you in the next video.